Once again, good day everyone to our co-presenter and also to our panel of evaluators. I'm going to present our study entitled Forecasting Tourism Competitiveness Rankings with ElasticNet, a TTDI-based approach. So this is a collaborative work by Epifil Nino Amora and myself, Jason Cano, from the College of Sciences and the College of Business and Management at Bohol Island State University, Candy High campus. Tourism is a vital economic driver worldwide. However, assessments of tourism competitiveness have traditionally been descriptive and retrospective. So the World Economic Forum's Travel and Tourism Development Index, or the TTDI, benchmarks destinations, but policymakers need forward-looking tools to anticipate future leaders. So our study addresses this gap by developing a forecasting framework to predict the TTDI rankings, enabling proactive and strategic planning. So there are three main issues we're emphasized here. First, the static assessments. TTDI analysis are descriptive and focus on past performance. The next is the policy gap. Governments require foreign or foresight to guide investments effectively. The third one is forecasting imperative. Predictive models can help identify emerging leaders and detect competitive shifts early. So our research workflow transforms raw TTDI data into forecasting ready inputs. First, we have the data acquisition. We collect panel data from the World Bank Data 360 platform. Okay. The second one is the preparation. So we remove redundant variables and carefully treated missing values. For example, using zero growth for initial years and country level averages for volatility. And lastly, restructuring. Data was arranged in panel format, preserving temporal order and country identifiers to allow leakage-controlled forecasting. To move beyond static scores, we engineered new features that capture the dynamics of competitiveness. So we included the lag features like TTDI at T1 and T2 to reflect persistence, growth, and momentum. We use this in the year-over-year growth rates. Also, the volatility and stability through rolling standard deviations and stability indices. And lastly, the fourth one, interaction terms such as TTDI multiplied by stability to count for nonlinear dynamics. So these features enable the model to capture not just current standing, but also trajectory, stability, and interactions among attributes. Then we compared multiple machine learning models, balancing predictive accuracy with interpretability for policy making. So the models were tested included the rinse regression, the lasso regression, the ElasticNet, the random forest, the gradient boosting machines, and support vector regression. And our evaluation metrics were policy aligned. First, the Spearman's rank correlation to measure consistency in rankings. Also, the Kendall tau for robustness in pairwise comparisons. And the third one, the precisions at 10 to evaluate accuracy in predicting the top 10 performers, crucial for governments. So our result show distinct strengths. First, the elastic net achieve the highest Kindle Tau with 0.749 and tied for highest Spearman's Raw, showing strong global ranking consistency and range um, regression achieved the best precision at 10 at 0.70, making it strong for identifying top performers. So this indicates that while range is useful for top tier accuracy, the elastic net is better overall for comprehensive benchmarking. So the elastic net stands out because it combines the strength of the range and lasso through its hybrid penalty. So it balances the coefficient shrinkage and feature retention, making it ideal for complex multicollinear datasets like TTDI. This results in better ranking consistency and policy relevance compared to other models. Our framework has three important policy implications. First is the strategic resource allocation. Forecast guide investments in infrastructure, branding, and sustainability. The second one is proactive policy design. Governments can anticipate emerging leaders and adapt policies accordingly. And the third, balanced perspective. The model accounts for both persistence and volatility, offering a holistic outlook on competitiveness. So here, the elastic net's transparent coefficient allow us to identify which factors drive competitiveness. So our results show that the raw TTDI value and the stability are among the strongest predictors. So this highlights that sustained, stable performance matters more than volatile surge in tourism competitiveness. In conclusion, this study demonstrates that tourism competitiveness can be forecasted reliably, serving as an early warning system for policymakers. The elastic net emerges as the most appropriate model for TTDI benchmarking due to its balance of accuracy, stability, and interpretability. For future work will include integrating macroeconomic indicators such as GDP, digital infrastructure, and international arrivals. Also, exploring ensemble blending for stronger predictive power. And lastly, developing a full policy decision support. It is a tool for governments and tourism boards. And the key takeaway here, ElasticNet provides optimal balance for forecasting tourism competitiveness, making it invaluable for global benchmarking and strategic planning. So this is the end of my presentation. God bless everyone.